So in the previous lecture, we have studied about linearly independent functions. How to show that the functions are linearly independent. First of all, those functions must be differentiable functions and they must be the solutions of some differential equations. Then to check that these functions are linearly independent, we will find out the Wronskian, and that Wronskian should not be equal to 0 for some point. At least one point you must be able to find where the Wronskian will not be equal to 0. So now let us take problems based on this. So exercise. Find the Wronskian of the set e raised to x e raised to minus x. So now how will I solve this problem? So Wronskian w of x is equal to, so it's a determinant which is, this is f1 and this is f2, this is f1, f2, f1 dash, f2 dash, which is equal to e raised to x e raised to minus x. The derivatives are e raised to x and minus e raised to minus x. So when I find the determinant, so this will be e raised to x into minus of e raised to minus x minus e raised to x into e raised to minus x. E raised to x into e raised to minus x is 1, because e raised to x into 1 upon e raised to x, that will be 1, and this will be minus 1, so which is minus 2. So the Wronskian is equal to minus 2. So what we observe is that this Wronskian is not going to be 0 for any x. It is not going to be 0 for any x. This means the Wronskian is always non-zero. It is never 0. So in this case, clearly the two functions e raised to x and e raised to minus x are linearly independent. So this set is a linearly independent set. So it is the best thing. Suppose your Wronskian comes out to be some number which is not equal to 0, then you don't really have to worry that can I find a point for which the Wronskian is going to be not equal to 0. So here it happens that the Wronskian is directly some non-zero constant. So my task is done and then the functions are clearly linearly independent. Let us go to the next exercise. Suppose I am taking two function now. Find the Wronskian of the set sine 3x cos 3x. Okay, so what is the answer? So this is my first function and this is my second function. So Wronskian of x is equal to f1 f2 f1 dash f2 dash, which is equal to sine 3x cos 3x 3 cos 3x minus 3 sine 3x. When I take the derivative of this, when I take the determinant of this, into minus 3 sine square 3x, then minus 3 cos square 3x, which is minus 3 sine square theta plus cos square theta. This fashion you get, which is 1. So I'm going to get minus 3. So again here the Wronskian of x is minus 3, which is not equal to 0 for all x. So this means that the two functions that we are talking, what are the two functions? Sine 3x and cos 3x are linearly independent. Therefore the set sine 3x and cos 3x is a linearly independent set. Okay, now let's go for, instead of taking two functions, now let us take three functions. So in this case the determinant will be of size 3 by 3. So let me write the question. Find the Wronskian of the set x, x square and x cube. Okay, so solution, and this is your function f1, f2 and f3. So Wronskian of x is equal to determinant. First row is functions x, x square and x cube. The second line is the derivative. The derivative of is 1, 2x and 3x square. The derivative of this line is, what is the derivative of 1? It is 0. Then 2x ka derivative is 2 and the derivative of this is 6x. Okay, now we have to solve this determinant and see what is the Wronskian. So I'm doing the calculations now, which is x into the determinant of this is 12x square minus 6x square. Okay, then minus x square into the determinant of this thing, which is 6x minus 0 plus x cube into the determinant of this particular block, which is just 2, right? Minus 0. Okay, which is equal to x into, which is 6x squared minus 6x cube plus 2x cube. So this and this I think cancels. I'm getting 2x cube. So the Wronskian is coming to be 2x cube. Now can we find a point for which the Wronskian is not equal to 0? So it is clear that if I put x equal to 1, say x not equal to 1, then what is the Wronskian at that point? The Wronskian at that point will be 2, which is not equal to 0. So by the earlier definition that I told you, that if you can find a point for which the Wronskian is not equal to 0, the functions will become linearly independent. Therefore the functions x square and x cube is a linearly independent set on the set of real numbers. Okay, because if you could find at least one point for which the Wronskian becomes not equal to 0. So let me I will show the screen again. If you have missed something, you can just see the calculation. Okay, we found the Wronskian. Now take one example in which you will actually get the Wronskian equal to 0. Okay, show that the set is 1 minus x, 1 plus x, and 1 minus 3x is linearly dependent. On R. Okay, now I will try to figure out what is the Wronskian. So what is Wronskian? So the first row is the three functions as it is, 1 minus x, 1 plus x, and 1 minus 3x. The second row will be the derivatives, which will be minus 1, 1 and minus 3. And the third row will be what? It will be completely 0. And if we know that if one of the rows or columns of a determinant is 0, then the value of determinant is also equal to 0. One row is 0 implies the determinant is also equal to 0. Even if one row is 0 or one column is also 0, then the determinant becomes equal to 0, right? Even if two rows are same, okay, two rows same. Suppose if you come across a problem in which two rows are same or two columns are same, still the determinant value becomes equal to 0. So this is equal to 0. The Wronskian is 0 for which x? It is 0 for all x. Take any x, you will always get the Wronskian equal to 0, and therefore the three functions 1 minus x, 1 plus x, and 1 minus 3x, this set is a linearly dependent set. Okay, so this set becomes a linearly dependent set. Now one should always ask that if these three functions are linearly dependent, means what should happen? Means if I take some combination of them, okay, if I take combination of some two people, I might be able to get the third person. Okay, this might happen. Okay, now can you see that how the three functions are, can you combine two functions from this and try to get the third function? Is there some relation between the three functions? Okay, so what I observe is that because why am I doing this? Because I've got the conclusion that they are linearly dependent. That is why. Okay, so if you look at the three functions carefully, 1 minus x, 1 plus x, and 1 minus 3x, okay, what you must be able to observe, you may have some different observation. So what I observe is that if I try to add them, if I try to add the second and the third function, what is f2 and f3? Okay, so I will get 2 minus 2x, and what this is equal to 2 times 1 minus x. Okay, and that is equal to 2 times f1. So what observation we have made, that what is the relation between f1, f2, f3? The relation between f1, f2, f3 is f2 plus f3 is giving me what? 2 times f1, means there is some relation which is connecting f1, f2, f3. Okay, remember that once you want to show that the three functions are linearly independent, okay, it is not necessary always to find this particular function to find this particular relation. It is we who are, out of our curiosity, we are trying to find that if they are linearly independent, then there must be certainly some relation which is connecting them. So here this is my observation. So I'll just write this as an observation. If someone asks you that if they are linearly independent, if they are linearly dependent, can you tell me the relation between the three people? So it is your observation which you have to make, and you have to conclude this particular type of rule. Not necessarily you have to always do this observation. Okay, so we know. Okay, now let me give you one more example. Well, you should now ask me that suppose I want to find a relation between the three functions. Is there any method for that, to find the relation between the three functions which will connect all of them? So let us do one simple problem. Question: find a relation. Now I'm teaching you the method. Here I told you observation. I'm teaching you the method. Find a relation that relates the three functions one minus x, 1 plus x, 1 minus 3x, given that they are linearly dependent. Okay, this relation is often called as functional relation. Means there is some relation between the given three or whatever the set is. Okay, now we will try to see how this comes, how I got this answer. So it is easy to do that. So I'll say let C1 F1 plus C2 F2. This is our definition of linearly independence, the original definition of linearly independence, plus C3 F3 equal to 0. So which is equal to what? C1 F1 is 1 minus x plus C2 1 plus x plus C3 1 minus 3x is equal to 0. Okay, why am I finding the functional relation between the three functions? I will repeat, because the set is linearly dependent. If the set is linearly independent, then there is no functional relation between them. There is no relation between the given functions. But I know here in this problem that the three functions are linearly dependent. Therefore, I am finding the functional relation. So now let us simplify this. What will I get? I will get C1 plus C2 plus C3, collected all constants together, plus x if I pull out common. I will get minus C1 and plus C2 and minus 3 C3 is equal to 0. And therefore comparing the coefficients, because right hand side everything is 0. Comparing the coefficients, what will I get? These are all constant. These are all terms which are coefficients of x. So I will get C1 plus C2 plus C3 must be equal to 0. And second relation is minus C1 plus C2 minus 3c3 is equal to 0. Now these three equations I'm supposed to these two equations I'm supposed to solve by, you know what, our system of equations. This was our system of equations. Like, what was the system of equations here? It is somewhat looking like what? X plus y plus z equal to 0 and minus x plus y minus 3z is equal to 0. So we have these equations. How do we solve these equations? So we will say that suppose the third equation is not given to us, but the third equation is 0x plus 0y plus 0z is equal to 0. So three equations and three unknowns, because 0 into x plus 0 into y plus 0 into z is always 0. So I'll write the three equations in the form of augmented matrix. Then second row is minus 1, 1 minus 3, and third row is 0, 0, 0 with 0 here. So this is the third equation. This is all is 0 and this is augmented form, and therefore I will do, if I look at if I add r2 and r3, r2 and r1, then what will be this equivalent to? I'm trying to find the augmented form. So this will become 1 1 1 and this is 0 here. Again, if I add this, I'll get 0 2 minus 2 and a 0 and 0 0 0 0. And if I divide the second row by 2, I will get what? I mean, this calculation is actually very easy. Okay, I am taking the help of matrices. If you know some different technique to solve the three equations, you can do that. I mean, add the equations and do some manipulations also. So I think this is okay. Yes. Now what I know is that this last row is completely 0. So your x is a leading variable, y is also leading variable. And z is free. So z is free. Who is my z? My z was c3. Okay. This means that c3 is a free variable. So c3 is free. So I can say c3 is equal to t. You can put c3 equal to t. T is any real number. Okay, this was your Gaussian elimination method, or which you have done in your first year classes. The second equation that I'm going to get from this is y minus z is equal to 0. So this means that y is equal to z, but z is nothing but c3, which is t. So y is also, so c3 is, so this means that c2 is t. Okay, and from the first equation what you get is x plus y plus z is 0, but I know that x plus t is 0, so x is minus 2t. But who was x? My x was c1, so c1 is minus 2t. So what are the values of c1, c2, c3? The values of c1, c2, c3 that we got is, so now this t is arbitrary, so let me just write what is c1 minus 2t, c2 is t, and c3 is also t. T is any real number, right? So if t is any real number, I'll say take t equal to 1. What will happen if I take t equal to 1? You can take any number. You can take t equal to 2 also. If t equal to 1, this will be in that, don't take t equal to 0. Otherwise, you'll get everything is 0. I'll get c1 is minus 2, c2 is 1, and c3 is 1. This c1, c2, c3, okay, I will substitute in the original first equation. Where was that gone? Here. Here I'm going to substitute c1, c2, and c3. 1 minus x, 1 plus x, and 1 minus 3x. minus 2 1 minus x plus 1 into 1 plus x plus 1 into 1 minus 3x is equal to 0. Substitute in star. So I got that minus 2 f1 plus f2 plus f3 is equal to 0, and therefore what is the functional relation between them? I'm getting f2 plus f3 is 2 times f1. So this is the functional relation. And this is, was this expected? Was this answer expected? What was the earlier relation that I mentioned you? The earlier relation that we observed. Okay, that was our observation. Where is it gone? Yes, see, f2 plus f3 is equal to f1. So I have told you the method. If you cannot observe, if you are not able to observe by looking at the functions, the functional relation, it's not a magic. You really have a method sitting behind this particular thing. So what is the method? Take the linear combination and make it equal to 0. Try to solve the two equations. If you are able to solve these two equations by some method which you already know, okay, by making some manipulation, adding these equations and doing some manipulations, you can do. But if you're not able to, just simply add the third equation as 0 0 0 x y z equal to 0, and just simply recall your Gauss elimination method, which says that make the matrix in the echelon form, find out the leading and the free variables, put the leading free variables as t variable, t, r, s, jo bhi hoga, find other variables, and then you've got, if you once you get all the solutions in the terms of t, just take any random value of t, which will not give all the constants equal to 0, otherwise there's no point in doing this. So then you'll get t equal to 1. Suppose I put t equal to 1, I'm getting the constants, and substitute the constant back into the relation. You will directly get the functional relation. Okay.